one thing to note that's interesting or worth really pointing out, reminding ourselves, is that in the last unit we were looking for factors. We were factoring. That's all we were doing. Solving, often we factor to help us solve, but it's not quite the same thing. Obviously, it's not the same thing as an equation that's got an equal zero, but what constitutes an answer also changes. So if you did the homework, you notice, and we talked about this a bit yesterday, but you notice that you can get down to an expression that's not factorable, and yet there's a solution there, right? There's an x-intercept. It's just not a fraction, not an integer, right? It's some kind of nasty decimal. But that's valid. That's a valid answer. So when we're solving, we do have to go a little bit further than in the previous unit when we were just factoring. Some of the answers could get down to, for example, you could get to something like, let's say you did a bunch of factoring, and you've got this, x minus 1, and then you've got x squared minus 10. X squared minus 10 is not factorable, but it is solvable. There is an answer to that, right? And so we have to continue and find the answer. If this equals 0, we have to keep going. And how would that look? Well, x minus 2, x minus 1, and then x plus something, x minus something. If that was 9, it would be a difference of perfect squares, and it'd be x plus 3, x minus 3. Why? Because 3 is the square root of 10. Sorry, 3 is the square root of 9. Getting ahead of myself. 3 is the square root of 9. So what's the square root of 10? Well, don't put a decimal, just root 10. Nothing wrong with that. If you had to graph it, it's going to be 3.09 or something like that, right? It's going to be really close to 3, just a bit over 3. And so if you had to graph that, you could graph it, you could put it in your calculator, figure out what it is, and make sure that your line doesn't go through 3, it goes through just past 3, just past negative 3, right? That would be fine. Like you could use that. But for solving, then if I was going to finish this, we're not graphing, we're solving. X equals 2, x equals 1, x equals negative root 10, and x equals positive root 10. So it has 4 solutions. Nothing wrong with that. The other way we could have solved that, x squared, what did I have? Minus 10. Yeah, minus 10. Let's say you remember this, hopefully from grade 10, grade 11, is I can move the 10 to the other side and take the square root of both sides. And don't forget the plus minus when you take the square root. Right? So that's the other way. If it was on its own, you could do that here by setting that part equal to 0 and get it. Like you could do it in that as well. That'd be fine. Okay, but that's the difference. That highlights some of the difference in when we're solving a polynomial equation versus in the previous unit just factoring. Okay, so we're going to remember about the discriminant because we're going to need it. And let's try the first one. Do you notice anything? Like I said, you have to be efficient with factoring. You can't see a degree 3 or degree 4 polynomial and just automatically start doing it through like our polynomial factoring, like synthetic division or whatever it is you choose to do. There might be an easier way. One of the questions on the learning goal, there was a much easier way to solve it. Should have only taken you, like the second question, should have only taken maybe 1 minute or less, 45 seconds, if you saw it, which you should. Okay, like you should be pushing yourself to look for those things. In grade 10, you could get away without doing it without knowing that. They were the challenging ones. Now it's par for the course. Now it's something we got to know how to do. Okay, we'll look that over after, but keep that in mind. So I would look, I don't know, I mean, it's not a trinomial, so there's nothing going on there. Factor by grouping doesn't look like you can. So in this one, I don't think you can, but you should always look, is there a simpler way of factoring than the long way? But I don't think so, so we're going to look for a, yep. Oh, do you know what is a factor?
Yeah, just like 1 minus 3 plus 5 plus 7, 15 minus 15, 0.
Ah, beautiful. So 1.
Yeah.
Okay. Right. 3 and 5 is 8 plus 7 is 15 minus 15. So that means we've got x minus 1 and so we'll have 3x squared and minus 7. And I need to get 5x squared. That's my goal. So there's negative 3x squared. What am I going to add to negative 3x squared to give me 5x squared? So 8x. So plus 8x. And then just check that. That's 8x squared minus 3x squared is 5x squared. And you can check it with the x's as well. So negative 7x minus 8x gives me negative 15x. And let's do the discriminant. So b squared minus 4ac. I'm going to write it out just for the lesson, just so if we're looking back at it later, we know what we did. But you don't, to me, the discriminant, like you don't have to show your work for that. I want to see that you've made the right choice moving forward, that you're not using the quadratic formula unless you have to, right? So if there's a question, now if you get the right answer, it's fine. It doesn't matter. You could use a quadratic formula for everything, I suppose. But you will run out of time if you do that. So you should always be using the discriminant to check. If you can factor it, then you should be factoring it. Okay, that's just rule of thumb. So this would be 8 squared minus 4 times 3 times negative 7, right? So I've got two negatives, so I'm going to end up adding. So it's 64 plus 4 times 3 times 7. 148. Not a perfect square. Therefore, we'll use the quadratic formula for that part. Oops, equals 0. So that means x equals 1 and x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where there's my a, there's my b, there's my c. Talked about this yesterday. Watch the negatives when you're square. This one's positive, b is positive, so I don't have to worry about it. But if b was negative, you're squaring a negative, so it should be in brackets. We already did this part. Thank you. It was 148. Who remembers how to, over 6, how to reduce radicals? How do I reduce that? Sam, what do you think? So like what? Very nice. So the square root of, remember, 4 times 37 over 6, which is negative 8 plus or minus 2 root 37. You actually take the square root over 6. And all of those things are divisible by 2, the 8, the 2 root 37, and the 6. So I can divide 2 out of all of them. So that's going to be 4, that's going to be 1, and that's going to be 3. And I end up with negative 4 plus or minus square root of 37 over 3. So that's two possible solutions. And then don't forget about that other one that we did earlier, x can be 1. And, question might ask you, like, there's the fully reduced exact answer. Unless otherwise stated, that's always what you do. You don't have to be told to reduce it. It's like a fraction. You always reduce. But it might also say give your answer to 2 decimal places or something like that. If it was a word problem and you had to interpret the answer, then you would have to do that, right? You'd have to, like, one of those might be negative. So figure out it might not be the right answer for that reason or something along those lines. Any questions? All right, let's try another one. This is like a kind of question I was talking about yesterday. So 3 things multiply to negative 18. That means one of them has to be negative 18. No, it's not the negative 18 product property, right? So there's no easy way to solve this. People look at it, and it looks like it should be 2x plus 7 times x plus 1 times x minus 2 equals 0. That's what it looks like. But it's not. It's equals negative 18. So there's only one way to solve this. How do we do it? Anybody want to guess? Yeah, you got to expand and simplify. It's the only way to do it. There's no, like, don't ever look at questions like this and think, oh, there's like a pattern. No. Expand and simplify. The only one you might be able to is if it's one of those, like, binomials squared inside a factoring question. We looked at those in the last unit. So it's like a trinomial factoring question, but with a binomial. I don't know if you know what I'm talking about. But anyway, you can look back at those. Sometimes those ones there's an easier way to factor, but not one like this. Okay, so why don't you go ahead and try expanding that. See if you can get the right answer. When you're done expanding, maybe wait. Like, I'm going to put the answer up in a second, but make sure you got the right answer before you start trying to factor, because otherwise it could be tricky. If you made one mistake, you might have something that's not factorable. It would be as easy as that, right? And then that would be a shame. I got 2x cubed plus 5x squared minus 11x plus 4 equals 0. So I move the 18 over. Everybody's different. People see these questions in different ways. However, like I have learned from my experience, which is quite a bit at this point, that fewer mistakes are made doing it a certain way. So if you're looking, like if you tend to make mistakes just doing expanding like this, you know how to do it, but you just make a mistake here or there, then maybe try to do it the same way I do it. That might help. So I chose to do the second two binomials first for two reasons. The main reason is it's easy because it's like just a simple binomial expansion, like really easy, straightforward. Right? I can do it in one step with very little work. Also, we are a little bit more familiar looking at the binomial times a trinomial instead of the other way around. You can flip them. For a lot of you, it might not be that big of a deal, but it does help a little bit. I think that the binomial is in front and then the trinomial is in the back. That's how textbooks always present those kinds of questions, or almost always. So, it's a little bit easier. I brought the 18 over, but I leave it to the very end, right? I can't add it in. Don't try to do that. That's like what grade 9s do. They start adding constants in way before they're supposed to, right? And then what I do is I do it in one step, but I do 2x times, and if you can't do that, then that's fine. Do it in 2 steps, but 2x times x squared, so that gives me my x cubed. Then I know two terms are going to give me the x squared, so I look at those. 2x times the negative x and 7 times x squared. So I do those all together, right? I just go, so that's negative 2x squared plus 7x squared, 5x squared. And then the 7 times the negative x, so negative 7x minus 4x gives me the 11x. Fast way of doing it, as long as you kind of recognize that. And I think there's enough of these kinds of questions in this unit that it's worthwhile having a bit of a strategy. Anyway, everybody good? Got that? 2x cubed plus 5x squared minus 11x plus 4 equals 0. Okay, so now try to factor it. See if you can get the next line. So yours could be a little bit different if you found a different factor. I used 1, x minus 1. And b squared minus 4ac gave me 81. Perfect square. What does that tell me? It tells me the nature of the roots. It tells me that they are going to be rational. Means fractions or integers, which means this is factorable. Right? That's what that tells me. B squared minus 4ac is 81. Perfect square. That means I can factor it. So I'm going to go ahead and do that. Go ahead. Try that. All right, there we go. Any questions about any of that? 1, 1/2, and negative 4. Feel good about it so far? Okay, so write down that little note. I'll give you a second to do that. We're going to talk about it. I sure can. Okay, so this says all factors, in other words, anything, like we're looking for factors, so we're gonna try to solve this degree 3 polynomial equation, right? So any factor that we find, we always look for a factor first. So we're gonna try 1, we're gonna try 2, we're gonna try 3. Well, we're not gonna try those in this case, but right, that's what you might do. Any of those things that you try that are going to be factors of this, that are going to, using remainder theorem, will give me a remainder of 0. Therefore, it gives us a factor. Okay, what this is saying is, any of those must be of the form m over n, where m is the factors, or could be all the factors of 7, which is the constant, right, in this case. So I'm using a particular example here, but if it was a different question, m, the one that goes on top, is the constant, and n, the denominator, is the leading coefficient, which is 6 in this case. Think if I found mx minus n as a root, so I would get this, mx minus n equals 0. So I move the n over and divide by m. I did that backwards compared to what's up there. That's okay. So mx minus n equals 0. Does that make sense? So these are the factors. We're going to look at one more thing. So just put your pencil down and relax for a second. I think this is easy enough to kind of remember, but I want you to try to make a connection, because I think this is important, sort of like thinking about connections of like making connections in the algebra, I guess. So this is one of the roots, so one of the answers. And when I actually solve it, right, the part that we didn't do in the last unit, but we're doing in this unit, remember, when I put that in, remainder theorem says I get the remainder of 0. Like, that's what makes it a factor. We've only looked at integers so far. But a fraction would work when it's of this form. It'll work the same way. Okay? And it came from that. So if I go back up to, let's say, this question right here, there's my 3 factors. So 1/2 would have worked. Here's what I want you to think about. X times 2x times x will always give me the leading coefficient of what I started with, which is here, this one right here, 2x cubed, right? That'll always, like, there's not going to be another x cubed. So if I multiply through here, these guys, x times 2x times x will always give me that leading coefficient. So these have to be, these coefficients, 1x, 2x, and x, have to be factors of the leading coefficient, which means the denominators, because that's where they end up going when I solve, have to be factors of the coefficient. And then similarly, -1 times -1 times 4 will always give me the constant, +4. right? And that's the numerator of all of those solutions to these equations. So if you look back, you can kind of make that connection back to that first line. And you can realize that any factors have to have factors of the constant, which in this case is 7. We don't worry about the negative, like obviously that factors in, but it's not, we try 7 and negative 7, we just try them both anyway. And then if those don't work, like we're going to try 1 and see if that works. But 2 won't work, 3 won't work, 4 won't work, 5 won't work, 6 won't work. So only 1 and 7, negative 1 and negative 7. Those are the only integer solutions that might possibly work. So try those. Everybody pick a different one and try it. Who tried positive 1? Did it work? No. Who tried negative 1? Did it work? Positive 7? And did it work? And did you do positive 7 and it worked? No. You did negative 7. So if anybody tried positive 7 and it worked, negative 7 works. But before we move on, okay, so we got a little bit lucky there. This isn't a really mean question. So negative 7 works, which means x plus 7 will be a factor. But before we move on and do that, if that didn't work, this is what you would have to do. We're going to do this anyway. And this is something that you need to know how to do. So it doesn't come up very often because it is a lot trickier. You're going to see like it makes things a lot more difficult. But it could come up, and it is something that you need to know. Okay, so here's what I'm going to do. I'm going to write down all the factors of 7. What are they? 7 and 1. Now I'm going to write down all the factors of 6. So what are they? 6, 3, 2, and 1. So actually, all the possible factors that you could try would be all the combinations of the factors of 7 on top and the factors of 6 on the bottom. So let's list them. Like this is something that you might have to do and then start trying different ones. So it would be something like, well, we already tried, and it's going to be plus or minus for everyone, so we're not going to write that every time. So it would be 7 over 1, 7 over 2, 7 over 3, 7 over 6. Or 1 over 1. Like 7 over 1 is 7, right? So plus or minus 7. Like that's the one we've been using the whole time. 1 over 1, that's the one those are always going to be viable options. 1 will always be a possibility for that reason. So 1's a factor of everything. 1 over 2, 1 over 3, 1 over 6. That's a lot of nasty decimals to try. And 7 is prime. 6 has a few factors, but not too many. Imagine you had numbers like 24 and 36 or something like that. Oh my gosh, that would be a disaster. Does that make sense? Yeah, one question, just looking for factors. So this is something that you should know, okay? You could even get a question just asking you what are all the possible factors that you could try. Like that could happen. You just have to list them. Any questions about that? All right, let's try this, but we got lucky. So go ahead See if you can factor that. I got 6x squared minus x minus 1. Discriminant's 25. This is factorable. And in fact, when you get really good at factoring, or like now that you're in grade 12, I don't know, maybe even grade 11, some of you started noticing this, but this is actually a simple trinomial in reverse order. You don't see this very often, but when there's a 1 here, it's kind of like if there was an x squared in the other way. So I can actually find two numbers that multiply to 6 and add to -1, and that will work. But the signs are a little bit different. So they're going to be like 3x, and 1, and 2x, and 1. And then which one do I want to be negative? I want the 3x to be negative. So x equals -7, x equals -1/3, and x equals +1/2. And if I compare that to our list, they're both in there. If I ever found myself in the situation where I tried all the integer possibilities and they didn't work, like if 7 didn't work, I'd start with a half. I think that's the easiest one. And then I guess a third, and if a quarter's in there, maybe that. And then after that, I don't know. There's no easy way to do it.